In this video, we'll be learning how to make a very basic 3D multiplayer game in Godot. To get started with multiplayer, we first need to learn two new terms. The first term is client. When you play a multiplayer game, your computer or your console or whatever device you're using to play the game is called a client. The other term we need to learn is server, and a server is the thing that connects multiple clients together so that they can play together, and it's responsible for making sure that data and information gets sent between the clients. So let's begin making our very first multiplayer game by starting with an empty scene. We're going to be making a lobby. This is the part of the game where you press a button, the game hooks you up with other players, and then you start playing. On the left, click on the 2D scene button, creating the main node, rename it to lobby, right-click on lobby and add a button node as a child. In the inspector, change the button text to host and rename the node to button host. After that, duplicate the button, move it down a bit, rename it to button join, and change its text to join. Attach a script to lobby and we can begin coding. Click on the button host node and in the inspector, click on the node tab, right-click on pressed, choose connect, and then press connect again. Now the button is hooked up and ready to run code when it's pressed. Repeat the same process with the join button. In the host button function, write var net equals networked multiplayer enet.new open close parentheses. This creates a new multiplayer network. You don't have to call it net, but that's just what I chose to do. Multiplayer enet is a built-in tool in Godot which takes care of a lot of the difficult networking involved with multiplayer games, and it's pretty easy to use. You can create your own network system from scratch if you want, but I don't know how to do that, so you're on your own. Next, we're going to write net.createServer6969, 2. This creates a server. This first number is the port number. You can sort of think of it like the server saying, hey, we're throwing a party at apartment number 6969. Come on over if you're interested. And this number can be pretty much anything from 0 up to something like 65,000, though you generally want to stay above 1024 since the ports below that number are usually reserved for more important things and you might have to get special permissions to use them. This second number is the maximum amount of clients that can connect to this server. I chose 2, but this can be as high as 4,096 clients. Next, we're going to write getTree.setNetworkPeerNet. I actually don't know what this line does, but I assume it's telling the server to actually start running or something along those lines. Let me know if I'm wrong. Finally, just to make sure the button is working, we're going to write print and in quotations, hosting. And so if we run the game and press the host button, hosting will appear in the console and we have successfully created a server. Now, let's create a client in the button join function. The code is almost identical to the host code, var net equals networked multiplayer enet.new, but this time we'll write net.createClient and in quotations 127.0.0.1, 6969. This creates a client. Every computer and server has a unique IP address, and here we specify which IP address to connect to. 127.0.0.1 is a special IP address that uses your own computer as its own server, which makes it easy to test out stuff like multiplayer. In real applications, you're probably going to use the IP of a different server or some other device dedicated to running your game, but for this demo, we're just going to keep it simple. The second number is the port number that we specified earlier. Finish it off by writing getTree.setNetworkPeerNet. So now we can host a server and we can join a server as a client. Now we need a way to start the game once everyone has joined. Up in the ready function, we're going to write getTree.connectNetworkPeerConnected, self, player connected. Network peer connected is a built-in function that detects when a client has joined a server. Here, we specify where we want the function to run. In this case, we want it to run in this very same script, so we just write self, though you can specify a different node if you want. And then we create a name for the function, and this can be anything you want as well, but I went with player connected. Then we're going to write func player connected and ID in the parentheses, and for now, we're just going to write pass. We'll be coming back to this in just a little bit, but now we're going to right-click in the file system window and select new script. We're going to call it globals.gd and press create. Double-click on globals and write var player2id equals -1. And don't worry, I'll be explaining everything very shortly. But next, go to project and project settings, and in the autoload tab, click the white folder icon, click on globals.gd and click open. Click on Add and make sure that it's enabled. What we just did is create a singleton, which is a script that runs independently of everything else in the game, and the code you write in it can be used anywhere else in the game. We'll be taking advantage of this a little bit later, but now let's create the actual game itself. Create an empty scene and click on 3D Scene to create the main node. Add a mesh instance node, give it a cube shape, and change its dimensions to make a platform. Add a camera so that we can see what's going on, and then add a position 3D node. This will be the spawn point for our first player, so move it to an appropriate place. Rename it to Player 1 POS. Duplicate it and move it to another location and rename it to Player 2 POS. If you want, you can add some lighting to make things easier to see. When we save the scene, we're going to call it game.tscn. Return to the lobby scene, and in the script, under the player connected function, write globals.player2id equals ID. And so when a client connects to the server, it's given a unique ID, which is just a random string of numbers, and that's what this ID keyword does. We're just going to store that ID in the player2id variable we created in our global singleton, then write var game equals preload, and then the path to the game scene dot instance open close parentheses. This prepares the game to be loaded. Then write getTree.getRoot.addChild game. And this adds the game as a child of the lobby. Then we hide the lobby so we can't see it anymore by writing hide open close parentheses. I've gone ahead and opened a second copy of Godot, and now I'm running 2 copies of the lobby scene. In one window, I'll click host, and in the other window, I'll click join. And when I do, the game should start on both windows. But right now there's nothing much to do, and so now we need to create some players. Create a new scene, click on the plus icon, and add a kinematic body node as the main node. And now we're going to create a basic character controller. If you don't know how to make one, watch one of my character controller videos because we're going to be going through this very quickly. Add a collision shape and give it a capsule shape. Add a mesh instance and also give it a capsule mesh. Change its color if you want. Add a script and then add some basic movement code. Pause the video if you want to copy it down. This is a very simple character controller that can only move left and right. The one thing that you might not be familiar with is this line here, if is network master. Basically, when you spawn multiple copies of a character controller into a game, if you don't specify which person owns which character controller, then you'll just be able to control all of them at the same time. The owner of a particular character controller is called the network master. So if you are the network master of this controller, then you can move the character. But if you aren't, then you can't control it. And every character controller only has one network master. When you save the scene, call it player.tscn. Next, return to the game scene and add a script to the main node. We're going to create a reference to the player spawn points that we created earlier by writing onReadyVar player1 pos equals $player1 pos and onReadyVar player2 pos equals $player2 pos. Then in the ready function, we'll write var player1 equals preload and then the path to the player scene dot instance open close parentheses. And this creates a copy of the player scene to spawn into the game. We'll then write player1.setName str getTree.getNetworkUniqueID. When we spawn in the players, every copy needs a unique name. And so to do that, we just change the name of the player to their unique ID that was established when they joined the server. Then write player1.setNetworkMaster getTree.getNetworkUniqueID, which specifies that this player owns this particular character controller. Then we write player1.globalTransform equals player1pos.globalTransform, which specifies the spawn point, and then add child player1, which spawns the player into the game. For player 2, it's almost the same thing. Var player2 equals preload and then the player scene dot instance. But this time when we set the name, we can't use getNetworkUniqueID because then it will just use the same ID as player 1, which means there will be 2 players with the same name, which might crash the game. If we go back to the lobby script, you'll remember that when a client joins the server, we saved its ID in the global singleton as player2 ID. Back in the game script, we can grab that player2 ID simply by writing str globals.player2 ID. Then we'll write player2.setNetworkMaster globals.player2 ID. Then we'll write player2.globalTransform equals player2pos.globalTransform add child player2. So now, once a client joins the server, the game will start and there will be 2 players in the game. But there's a problem. If you click on this window, you can move one of the players, but it isn't moving in the other window, which means they're not currently communicating with each other. And obviously this is a problem for multiplayer games. To fix this, go back to the player scene, and in the script, we're going to create a special type of function. Remote func set position pos global transform.origin equals pos. Then at the bottom of the script, write RPC unreliable and in quotations set position, comma, global transform.origin. So this is where things can get a little confusing, but I will try my best to explain. RPC stands for Remote Procedural Call. It's a way for clients to communicate information with each other. We won't get into too much detail in this video, but there are a couple different types of RPC, like RPC ID and RPC Unreliable, and they're useful for different types of communication. RPC Unreliable is good for things like player position, so that's what we're using here. So basically, we're saying that we want to run this set position function, and we want pos, or position, to be the player's current location, or global transform.origin. And so if you are the network master for this particular controller, then you can directly move it using your own keyboard or controller. But if you aren't the network master, then its position will be remotely controlled by the other player using the set position function. And of course, this is true for all players in the game, and so your own position will be remotely controlled for the other players in the game so that everyone's position is synchronized across the network. I know it's a little bit confusing, but this is just a bare basics video and we can go into greater detail in upcoming videos. Now there is going to be one more issue, but let's run the game anyways. So now when you move a character, its position gets updated for all players. The problem you might notice is that the player's movement is very jittery and slower than expected. And you might even have problems with controlling the wrong player or players teleporting to random places when the game starts. And I don't know why this happens, but thankfully I've found an easy fix. In the player script, write, if direction does not equal vector 3, then highlight this code, right-click on it, and select indent right to bump the code over to the right. Basically, it will only bother updating the position if the character is actually moving. Otherwise, it won't do anything. So now, when you run the game, the jitter is gone and everything works smoothly. And with that, you now have a very basic understanding of 3D multiplayer in Godot. Now, when it comes to making an actual game, things get a little more complicated, and some of these things will need to be modified or changed in order for everything to work correctly. But those are all things that we can tackle in future videos on this topic. Let me know what kinds of things you'd like to learn about regarding multiplayer, and let me know if I got anything wrong since I'm still learning this stuff as well. Anyways, thanks for watching. Like, subscribe, and bell to support the channel. Consider buying me a coffee, links below if you're feeling extra generous. Join the Discord, follow me on Twitter, and as always, have a nice day.